Hello everyone, welcome to our new lecture series on the electricity, magnetism and electromagnetic theory. This is Dr. Rahul Shrivastava, Assistant Professor, Faculty of Science, Physics, the Bhopal School of Social Sciences, Bhopal. As we are going to start our new lecture series on this particular topic, so first topic about the static electricity and charge. So let me start with the static electricity. The general experiment we do almost every day, that once we rub two objects with each other, they are capable to attracting some lighter objects. Like, let me take an example of this little girl, which is she is combing her hair with a particular red comb, and this particular object or comb is capable to attracting the lighter objects, or we can say, as we are seeing in the image, that the specific pieces of paper. So this property of attraction or attracting property of light bodies is known as the static electrical properties, and static electricity is all about that attracting the lighter object by the harder object by the transfer of charge. So why actually it is happening? So because the amount of particle that is traveling from one object to another object, and this phenomenon is known as the electrifying or the static electricity. The object which is capable to attraction or acquiring this attraction property is known as the electrified object, and the electricity which is produced during this phenomenon is known as the static electricity. So in this particular example, this comb is basically electrified or is capable to attract the other objects or the lighter bodies. The other object, which are these piece of papers, which are easily getting attracted by this piece. So this comb is known as the electrified object, and the electricity which is produced during this portion is known as the static electricity. So why actually this is happening? Because as we all know that each and every substance is made up of various atoms, or we will say it as the atomic structure of any material, and in this structure we all know that at the center point we are having a nucleus. A nucleus is nothing, just a composition of various particles, and these particles are the proton, neutrons and some other also there, but we will discuss only protons and neutrons. Since protons are having positively charged particles, they are having a positive charge, and also some uncharged particles which are known as the neutrons. So we can see that almost in the center. I am not saying it's center because as we all know that the neutron nucleus are not in the exact center of the material, just like the solar system of our earth, that sun is not in the exact center, and the path is also the elliptical for the earth. So that's why we are having the summer and winter season, because of the distance calculation. Now, as this nucleus is not in the center, it is in the elliptical path, it is a composition of positively charged protons and uncharged neutrons. Surrounding orbits are also created, just like the earth is orbiting there, or the revolving. Because of this revolving portion, one orbit or one cell developed there, and the negatively charged particles, which are known as the electrons, which continuously revolve in these orbits. So this revolving portion continuously happening there, and the negative charge particles continuously revolving there, also spinning there, just like our earth is revolving and spinning. In 365 days, it is completely one rotation or one revolving is there. Also the spinning 24 hours complete spinning. So same behavior is also giving by the electrons. They are continuously revolving around the sun, and also they are spinning at their own axis. So similar behavior also showing by the electrons. Just like the sun, in the particular place, nucleus is there, and nucleus is basically a composition of positively charged protons and neutrons. Alright, this is what about the atomic structure of any material or substance. As we all know that electrons are having the negative charge and protons are having the positive charge, but the magnitude of charge is equal to them, means whatever the amount of charge is there, it is equal to the positive charge of protons. So the magnitude of charge is equal for both the particles, and also the number of particles, means the number of electrons, are also equals to number of protons. So we can say that the total number of negative charge particles are equals to the total number of positive charge particles. So we can say that overall the total charge positive and negative are equal. So, naturally, or we can say that the electrically every substance or material is neutral. Why? Because the negative charge equals to positive charge, both charge are cancelled. So, there is not any specific charge on any material naturally. Once we rub, naturally it is happening, but once we rub two objects, once we are rubbing two objects, like I am rubbing my both hands, because of this rubbing portion, the electrons from one object transfer to another object. And why it is happening? See, because this is the orbit, I am not discussing in the first second, this is the outermost orbit and it is completely bounded with the nucleus there. So, electrons which are there and protons are there, they are having the attraction force and continuously revolving there, but the electrons which are in the outermost core are least bound to the neutrons or to the nucleus, and also some materials are having loosely bound properties there. So, once we rub these materials with each other, electrons from one object transfer to another object, and because of this transformation, some electrons are coming out from their outermost cores and transferring to other object, which is the basically a transfer of charge from one object to another object. So, when two substances rubbed with each other or together, the electrons from one substance, in comparison, whichever the material is having loosely bound electrons will transfer or will travel from one object to another object, and because of this traveling or transferring of electron, first substance in which the electrons are removing or traveling from this object to another object, or because of the loss of electrons, the first object will become positively charged, which have loosed the electrons, and another material or another object or substance which is having or absorbing these electrons will have the negative charge. Also, some mathematical theory is there, because electrons, let me take an example, two electrons are transferring from from this object to that object. So, here we are having the two additional protons there. So, this will have the positive charge and also lose some electrons, and it is having additional two electrons, and because of these additional two electrons, it will acquire or it will have a negative charge. So, in comparison, we can say that the positive charge it is having because of the losing electrons and also because of the additional protons which are not getting equal magnitude with their compatible particle, and it is having additional two electrons or not having compatible positive particles. So, that is why it is having the negative charge, and this particular is having the positive charge. Let me take some examples there. First one, when we rub the glass rod, when we rub the glass rod with the silk, we have already studied this in multiple books, that when we rub glass rod or the glass material with the silk, the electrons from the glass rod travels towards the silk, or the electrons come out from the glass and get in the silk material. So, we can say that in comparison to the silk, the glass rod materials or the glass rod electrons are loosely bounded. So, they can easily come out from their orbits and getting transferred from glass to rod. As we can see in the image also, see the glass electrons are particles are from glass rod traveling from this place to the silk. So, it is having multiple negative particles there and it is having multiple positives there, and because of this the glass rod will have the positive charge, or we can say that this glass rod will be positively charged and the silk will get a negative charge or negatively charged. Another example, when the ebonite rod getting rubbed with fur. So, in this case we are having the reverse phenomena. The particle or the electrons from the fur will travel towards the ebonite rod. See, this is the fur, the person is rubbing on it and it is having the additional electrons there, and because of this the additional electrons, the ebonite rod will become negatively charged and the fur will become positively charged because of the losing particles and also because of the absorbing some additional electrons, the ebonite rod will become negative charge. All right. So these are the some basic description that why any object is capable to absorbing or attracting some lighter weight particles or some lighter weight substances. So basically one important part that come out from this particular discussion is the charge. So charge we have discussed, that is the positive charge, negative charge, how a particular substance is getting positively charged and how any substance is getting negatively charged. So basically we can say that charge is having two types or two kind, positive charge as well as the second one, negative charge. And we can say that among these two bodies getting charge on rubbing, the charge on one body is having equal magnitude with the other charge. See, equal in magnitude. Positive magnitude will equal the negative magnitude. So in magnitude there is a specific same value there, but the nature will be completely opposite. That is the important thing. The nature of these materials will we have, or the nature of these materials, like one material is having positively charged, another one is the negatively charged, they will have the same magnitude, same power, but opposite behavior. One will have the negatively charged, another one is positively charged. They will have the behavior depending on the charge value, because the magnitude is same. Also, what this behavior will be like, that same charge, this is the natural phenomenon, the same charge always repel each other. See, this negative one and this is the negative one, they are repelling each other. The same charge also, if we are having the same case of the positive also, they will repel each other, they will not come out or they will not come close to each other, they will repel each other, they will oppose each other. But once we are having the opposite charge like positive and negative, they will attract each other. Means the opposite charge or unlike charge will attract each other and the same charge will repel each other. Remember, the magnitude will be same for all. Now, also some law and property and conditions is there for the charge. Law of conservation of charge, as we have discussed or already know about the law of conservation of energy, like energy neither can be created nor be destroyed. Similarly, charge also cannot be or neither be created and nor be destroyed. Charge can transfer from one object to another object, just like energy can transform from one form to another form. Charge also can transfer from one object to another object. So in an isolated system, the charge can neither be created nor it can be destroyed, and this is what the law of conservation of charge. I will explain you with some examples there. The image is shown, A portion, B portion, and C portion. So see, in the first image of this A, the positive 2, negative 2, C, positive, negative. These positive and negative are having equal value. मतलब positive protons, negative electron. So the net charge, so this net charge is 0. Similarly, we are having another object like the cloth is there. We are not going specific whether it is fire or silicon, whatever it, let it be. So it is having let 3 positives, 1, 2 and 3, 3 negatives. So the net charge, because of plus 3 and minus 3, will be 0. So naturally we are having neutral materials or the neutral substance or the neutral behavior of any material there. In the B portion or B section, we will rub these two objects. And because of this rubbing, what will happen? That some of this particle travel from this cloth to this object. We can have the example from the ebonite rod and the fur. It is also a kind of this. Ebonite rod is absorbing the electrons and the fur is transferring electron from their own. Like here we can see that 2 electrons, see, additional, counted, 1, 2 positives, 1, and 2 positives. So positives are same. Positives are same. Negative 1, 2. Here we are having 1, 2, 3, and 4. Means additional 2 electrons that has been transferred or come out from this cloth towards the object. So that's why we are having 2 positive protons there and 4 negative electrons there. And because of this positive negative, let me clear all these. And because of this positive and negative, the net charge here is -2. Compare it with this. Before it is having net charge 0 and now it is having net charge -2. So we can say that this particular object is negatively charged. Negatively charged. Now, in the case of this cloth, see what is actually happened. See 1, 2, and 3. 3 protons. 1, 2, and 3 protons are there. But the electrons are also 3 there. But we are here having only single electron. So 2 electrons, the additional 2 electrons that came out from this particular cloth, and that's why we are having additional 2 protons there, and the net charge is +2. Net charge is +2. So if I am cleaning it again, overall what this particular phenomenon happened here, before this it is having the net charge 0 and now it is having the net charge -2. So after this rubbing process, this object become negatively charged, and this particular cloth before it is having net charge 0 and after this rubbing process the net charge is +2. So it has become positively charged and it has become negatively charged, and this is how every object, every substance will get charged, either positively charged or negatively charged. So the amount of positive charge acquired by an object is always equals to the amount of negative charge acquired by the other object. So if we are totaling it, we are equaling it, that is completely equal to each other, and the magnitude will be same for each other, and the amount of particles that travels from one object to another object, if we are calculating it, the let in this case 2 electrons coming out from this object and 2 electrons has been absorbed by this object, so it is positively charged by +2 charge particles, it is negatively charged by -2 particles. So this is all the law of conservation of charge. Now about the quantization of charge, also the word quantization means the charge is always having the integer multiple numbers, exact integer number 1, 2, 3, 4, 5, and whatever the amount of rubbing we are doing, the amount of, so always we will have the equal number of particles and quantized particles. So where in formula as we have seen, q is equals to plus minus ne, where plus symbol is showing for the positively charged proton or the positively charged material, and while the negative is showing for the negative electron or those negatively charged material, or also n is equals to 1, 2, 3, 4 or an integer number. And e, I am continuously saying the charge, the amount or the value or the magnitude of charge will be this. E is equals to 1.6 into 10 raised to the power -19. Remember this. This is the value of charge. And also plus minus. Plus for the proton, minus for the electron. E is equals to plus minus 1.6 into 10 raised to the power -19. I am not written the unit here. We will discuss in the next following slide. So 1.6 into 10 to the power -19. The unit I will tell you in the next slide. I have not written there. Plus is for the proton and negative is for the electron. Now quantization means Q is equals to plus minus Ne. For the case of proton, Q is equals to, let me take an example of one proton. So Q is equals to plus 1.6 into 10 raised to the power minus 19 for proton, minus 1.6 into 10 raised to the power minus 19 for an electron. Now, if we are taking the case of two particles, okay, how much amount or magnitude getting charged? We have discussed 2 electrons, 4 electrons, this and that. The electron or the value of electron meaning is the 1.6 into 10 raised to the power minus 90. Multiply it with 2, 3, 4 with 10 particular integer number. So this is what the quantization of charge. Now also unit of charge. Here I am going to tell you. The unit is coulomb. I can also tell you before also, but I want to be get highlight this particular unit. Coulomb. In the following next lecture, we will discuss about the Coulomb's law and why we have given the name Coulomb. Coulomb is a scientist, one of the fine scientists of, or a physicist a universe or an earth can have, and on his name, and it is our honor to give the name of Coulomb of charge, because he discovered these phenomena. Whatever we have discussed on in this particular lecture is defined and described by the Coulomb. So on honoring him, the unit of charge is given as Coulomb. So Coulomb basically, how he has explained that charge basically equals to current into time, and the unit of current basically we all know as the 1 ampere multiplied by the 1 second. So basically 1 coulomb is equals to 1 ampere second. So this is the unit of charge. So this particular lecture we have already covered a lot about the static electricity, how the materials are getting charged, how they are getting positive charge and positively charged or the negatively charged. In the following lectures we will discuss about the Coulomb's law, that how this charge or the force that acting in between, that in particular slide we have discussed that the like charge or the same charge will repel each other and the opposite charge will attract each other, and this phenomena or this force that we have discussed is defined by the Coulomb, and we will further discuss in the next following slide or the next following lecture. So for today's, thank you so much for your kind attention. This is Dr. Rahul Shrivastava from BSS Bhopal. Have a nice day.